Hello everyone, today we'll be discussing the quick solutions of All India Akash Test Series, Test 6A Paper 2 Mathematics, which was held on 16th February 2020. Let's start with section 1, that is integer type question. So question number 41 says that if integral from 0 to pi by 4, square root of 2 plus tan square x dx is equal to ln square root n minus 1 plus square root n plus 1 divided by square root n plus pi by m. So we have to find n plus n. See, to find this integral, firstly, let us substitute 2 plus tan square x equal to t square. So differentiating both sides, we will get 2 tan x into secant square x into dx is equal to 2t dt. So 2 is cancelled. So let us say the integral is I. So I is equal to integral. When x is 0, then it is square root 2. When x is pi by 4, then it is root 3. And square root of 2 plus tan square x is t into dx, and that is dt divided by tan x, that is square root of t square minus 2 into secant square x, that is 1 plus tan square x. So it is t square minus 1 into t, right? Now this can also be written equal to integral from root 2 to root 3. See here in the numerator, let's subtract and add 1. So it is t square minus 1 plus 1 divided by square root t square minus 2 into t square minus 1 into dt. That can further be written equal to t square minus 1 divided by square root t square minus 2 into t square minus 1. So t square minus 1 is cancelled. So it is integration of 1 by square root t square minus 2 into dt from root 2 to root 3 plus integral of 1 divided by square root t square minus 2 into t square minus 1 into dt from root 2 to root 3. Now first integral is quite simple. We know the direct formula. It is ln mod t plus square root of t square minus 2, and the limit is from root 2 to root 3 plus. Now to find the second integral, let's put t equal to 1 by z. So we have dt equal to minus 1 by z square into dz. So integral is from 1 by root 2 to 1 by root 3 minus 1 by z square dz square root of 1 by z square minus 2 into 1 by z square minus 1, right? Now this is further equal to putting the limits ln mod root 3 plus this is 1 minus ln putting root 2 square root of 2 minus 2, that is 0. So it is ln root 2 plus. Now here we get integral minus z into dz divided by 1 minus z square into square root of 1 minus 2 z square, right? And the limit is from 1 by root 2 to 1 by root 3. Now again, let's put 1 minus 2 z square equal to m square to remove the radical sign. So from here we will get minus 2 into z into dz is equal to m into dm, cancelling 2 on both sides. So let us say the second integral, let us say this is I1. So let's solve I1 now. This is equal to integral. So when z is 1 by root 2, this is 0. So it is 1 minus 2 by 3, that is 1 by 3. So it is 1 by root 3 minus z into dz, that is m into dm divided by 2 into 1 minus z square. This is 1 minus z square is 1 minus m square divided by 2 into square root of 1 minus 2z square, that is m. So m is cancelled. So this is equal to integral from 0 to 1 by root 3 dm divided by 2 into 2 minus 1, that is 1 plus m square. So this is also cancelled. Now its integral is quite simple, that is tan inverse m 0 to 1 by root 3. So tan inverse 1 by root 3 is pi by 6 minus 0. So the required value of I is equal to ln mod root 3 plus 1 divided by root 2 plus pi by 6. So comparing with the right hand side, we can see value of m is equal to 6 and value of n is equal to 2. So n plus m is equal to 8. So 8 is the required answer. Next is question number 42. Consider a function fx that is maximum of sin x comma cos of fractional part of x for x going from 0 to pi. So the number of points where fx is not differentiable is. So let's solve this question. We have to make the graph of both the functions. Firstly, let us make the graph of sin x from 0 to pi. And this is pi by 2 and this is pi comma 0. Right? This is the origin 0 comma 0. Now we have to make the curve of cos of fractional part of x. Let us say here we have pi by 4 and here we have 1. So from x going from 0 to 1, it will behave as cos x, right? So it will pass through this point, it will start from this point, and so the curve is like this, right? Now on similar pattern from 1 to 2 and on similar pattern from 2 to 3, the graph will be like this, from 2 to 3 and then from 3 to 4. They all will be starting from y equal to 1. So the graph is like this. Now we are talking about maximum of these two. So it is this portion. Then from 2 to 3, the maximum is this one. But we have to look up to pi only. So here we can see the number of points at which it is non-differentiable is 1, 2, 3, 4, 5. So these are the 5 points at which the function is non-differentiable. So we have 5 as our required answer. Next is question number 43, which says if a plus b plus c is positive and abc is equal to minus 1 by 10 and consider a matrix A such that A is orthogonal, then we have to find the value of 10 into a cube plus b cube plus c cube. See, A is orthogonal, which means that A transpose into A is equal to I. So let's find A transpose. It is ABC, BCA, CAB. That is same as the given matrix because it is a symmetric matrix. So multiplied with A, that is CAB. This is given to be equal to I, that is identity matrix, whose diagonal elements are 1. Now multiplying these two, we can see A square plus B square plus C square, and here AB plus BC plus CA. Here AC plus BA plus CB. Similarly here AB plus BC plus CA, A square plus B square plus C square, AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA, A square plus B square plus C square. This is given to be equal to 100,010,001. Right? So comparing, we can say value of A square plus B square plus C square is definitely equal to 1 and AB plus BC plus CA is equal to 0. Right? And ABC is also given to us. Now from here we can find A plus B plus C. We know the identity, its square is equal to A square plus B square plus C square plus 2 into AB plus BC plus CA. So this is equal to 1. Now A plus B plus C is always positive. So we have only one value of A plus B plus C, that is equal to 1. Minus 1 is rejected. Right? Now we have to find the value of a cube plus b cube plus c cube. Now we have another identity that a cube plus b cube plus c cube is equal to 3abc plus a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So further putting the values, this is equal to 3 into abc, that is minus 3 by 10, plus a plus b plus c is 1 into a square plus b square plus c square, that is again 1 minus 0. So this is equal to 1 minus 3 by 10, that is 7 by 10. So value of 10 times this is 7. So 7 is the required answer. Next is question number 44. If A, B, C are the vertices of a triangle ABC whose circumcenter is O, that is Z0, where Z1, Z2, Z3 and Z0 are complex numbers, then the absolute value of this term is what we have to find. So we are given a triangle over here, that is ABC, and its vertices are given Z1, Z2 and Z3. Circumcenter is also given, that is O, that is Z0. As it is the circumcenter and this is angle A, so we can say this angle is 2A, this angle is 2B and this angle is 2C. So we can apply here rotation method. Here we can see in clockwise direction Z0 minus Z1 divided by Z0 minus Z2, as modulus of these both are same, that is OA is equal to OB, so this is directly equal to e raised to the power minus iota into 2c. Similarly, applying rotation method here, we can say Z0 minus Z3 divided by Z0 minus Z2 is equal to e raised to the power iota 2a, because here also this side is equal to this side. Now we need the value of Z0 minus Z1 upon Z0 minus Z2. So here putting the value of this one and putting the value of this here. So we will get e raised to the power minus iota 2c, that is cos 2c minus iota sin 2c into sin 2a divided by sin 2b plus, here we have cos 2a plus iota into sin 2a into sin 2c divided by sin 2b. We have to find the value of this one. Now this is equal to sin 2b can be taken common in the denominator. So we have cos 2c sin 2a plus cos 2a sin 2c as the real part, and the imaginary part is minus sin 2c sin 2a plus sin 2a sin 2c, that will cancel. So we are left with only this term. Now this is equal to sine of 2a plus 2c divided by sine 2b. So this can be written equal to sine of 2 times a plus c can be written as pi minus b. So this is pi minus b. Now divided by sine 2b. Now 2 pi minus theta, that is equal to minus sine 2b divided by sine 2b. So this is equal to minus 1. But in the question it is asking for the absolute value. So absolute value will be equal to 1. So 1 is the required answer. Next is question number 45. The remainder when 2 raised to the power 4 raised to the power 60 is divided by 7 is. Firstly, let's talk about 4 raised to the power 60. Now, as this can be written equal to 1 plus 3 raised to the power 60. So if we expand it, we can see this is of the form 1 plus 3 lambda. Let's write this as 1 plus 3 lambda. So we have 2 raised to the power 1 plus 3 lambda, that is equal to 2 into 2 raised to the power 3 lambda, that is 2 into 8 raised to the power lambda, that is 2 into 1 plus 7 raised to the power lambda. So if we expand it, we can see that this is equal to 2 into 1 plus 7m, right? Now the remainder when this is divided by 7, this will give 0 and this will give 2. So 2 is the required answer. Next is question number 46, which says if alpha minus beta is 3 pi by 2 and beta is equal to gamma minus alpha, then the value of cot beta cot gamma plus cot gamma cot alpha divided by cot alpha cot beta is. So the value which we have to find, let's multiply in the numerator and denominator by tan alpha, tan beta, tan gamma. So what will we obtain? We will obtain tan alpha plus tan beta divided by tan gamma. The required value, let us say this is equal to, now we are given two equations, so we can convert alpha and gamma in terms of beta. Let's do that. Tan of alpha can be written 3 pi by 2 plus beta plus tan beta divided by tan of gamma. Gamma is beta plus alpha, that is beta plus 3 pi by 2 plus beta. Now, see, let's consider this as one angle and this as another angle. So we know tan of A plus B, that is tan A plus tan B divided by 1 minus tan A tan B. So this is tan of 3 pi by 2 plus beta plus tan beta divided by tan of A plus B, this is tan beta plus tan of 3 pi by 2 plus beta whole divided by 1 minus tan beta into tan of 3 pi by 2 plus beta. Now it can be seen that these two will get cancelled. So this is equal to 1 minus tan beta into tan of 3 pi by 2 plus beta. Now this is equal to 1 minus tan beta into tan of 3 pi by 2 plus beta. See, this will convert into cot beta with negative sign. So here we have plus. So this is equal to 1 plus 1, that is 2. So 2 is the required answer. Next is question number 47. Let m comma n belong to natural number. The probability that 7 raised to the power m plus 7 raised to the power n is divisible by 5 is p by q. Then we have to find q minus p. See, here this should be divisible by 5. So let's firstly find 7 raised to the power 4k. This is of the form 5 lambda plus 1. Similarly, we can see 7 raised to the power 4k plus 1 is of the form 5 lambda plus 2. 7 raised to the power 4k plus 2 is of the form 5 lambda minus 1, and 7 raised to the power 4k plus 3 is of the form 5 lambda minus 2. Now, we need that sum of these two should be divisible by 5. Now, this can be obtained when we take two numbers of these two types or we take two numbers of these two types, right? So, required probability of, let us say, event E is equal to, first number can be selected of any kind. Now, by 4C1 ways, I have selected first number of any kind. So, correspondingly, second number can be obtained according to that, right? If we select this one, then we will select the other number of this form. So, for second number, we have only one way. So, this is the required number of ways divided by total number of ways. From the 4 given numbers, we can select any for both of them. So, required probability is equal to 1 by 4. So, this is equal to P by Q. So, Q minus P is 4 minus 1, that is 3 is our required answer. Next is question number 48, which says in a triangle ABC, D, E and F are the midpoints of sides BC, CA and AB respectively. Let angle A is pi by 6 and side A is 3 by 2. O and H are respectively the circumcenter and orthocenter of triangle ABC. If AH into BH into CH is 3, then 4 times OD square plus OE square plus OF square is. See, angle A is given and side A is given. So we have A upon sine A is equal to value of 2R. So this is equal to 3 by 2 divided by sine 30, that is 1 by 2. So this is 3, which means that value of R is 3 by 2. Now, AH into BH into CH is given. Now we know that AH is equal to 2R cos A. Similarly, BH is equal to 2R cos B and CH is equal to 2R cos C. So we are given product of these three, that is 8 into R cube, that is 27 by 8 into cos A cos B cos C is equal to 3. So this is cancelled. So we have from here cos A into cos B into cos C is equal to 3 by 27, that is 1 by 9. Now we know that cos 2A plus cos 2B plus cos 2C is equal to minus 1 minus 4 times cos A cos B cos C. So applying this here, we will get minus 1 minus 4 by 9, that is minus 13 by 9. Now we need the value of 4 into OD square plus OE square plus OF square. We know that OD is equal to R cos A. So we need the value of 4 times R square into cos square A plus cos square B plus cos square C. Now value of this can be easily found because we have the value of cos 2A plus cos 2B plus cos 2C. So we can write this equal to 2 into cos square A plus cos square B plus cos square C minus 1 minus 1 minus 1, that is minus 3. So we can say 2 into R square into 2 times this value is equal to 3 minus 13 by 9, that is equal to 2 into R square, that is 9 upon 4 into 27 minus 13, that is 14. So 9 is cancelled. So this is equal to 14 by 2, that is 7. So 7 is the required answer.